Let's discuss about metals and non-metals, part 2, class 10 NCERT. Our first topic is occurrence of metals, the elements or compounds which are occur naturally in the earth crust. This is known as minerals. At some places, the minerals contain very high percentage of the particular metal, and the metal can be profitably extracted from its ores. The next one is extraction of metal. By using reactivity series of metal, we can easily understand how a metal is extracted from its ore. This is the reactivity series of metals. From top to bottom, the reaction of the metal decreases. In the topmost position, potassium, sodium are there. These are the most reactive metals. And the bottommost level, gold, silver, these are the least reactive one. The least reactive one are found in the earth crust as the free state. But the most reactive one will not be found in the earth crust in the free state. They are only found in compounds. Metals at the top of the reactivity series is very reactive. That's why they react with the other elements and form compounds. The metals in the middle of the reactivity series is moderately active. So they found in the earth crust mainly as oxides, sulfates or carbonates. Also many metals are oxides because oxygen is very reactive element and is very abundant on earth. On the basis of reactivity, the metals are grouped into three categories. The first one is metals of low reactivity, then medium reactivity, and of high reactivity. According to this reactivity, different techniques are used for obtaining the metals. From this table, we can see that metals of high reactivity they mainly used electrolysis method, and for the medium reactivity they use reduction using carbon, and low reactivity they found a native state. Next one is enrichment of ores. The ores are mined from the earth are usually contaminated with the soil or sand. These type of impurities are called gangue. These impurities must be removed from the ore prior to the extraction of that metal. Several steps are used for removing gangue from ore. These are based on the difference between the physical or the chemical properties of the gangue and the ore. Next one is extraction of metals in the middle of the activity series. As we all know, in the middle of the activity series, the metals are moderately reactive. These are usually present in sulfates or carbonates in nature. When we compare sulfates and carbonate with oxides, it is easier to obtain metal from its oxide. That's why prior to reduction, the metal sulfates and carbonate must be converted into metal oxides. There are two techniques are used, that is roasting and calcination. For sulfide ores, it is converted into oxide by heating strongly in the presence of excess air. That is called a roasting. And for the carbonate ores, they are changed into oxides by heating strongly in limited air. This is called a calcination. This is the step-by-step process of the extraction of metals in the middle of the activity series. When the ore is carbonate, then calcination will be done, and when the ore is sulfide, roasting will be done. After that, we get the oxide of that metal. Then reduction of that metal will be done, and after that, purification of metal. The chemical reaction that takes place during roasting and calcination of zinc ores is given below. For roasting purpose, we use sulfide ores and it is heated in the excess of air. We get zinc oxide. In the calcination process, we use carbonate ore and it is heated in limited air. Then we get zinc oxide. The metal oxides are then reduced to the corresponding metals by using suitable reducing agents such as carbon. For example, zinc oxide is heated with the carbon, it is reduced to metallic zinc. The chemical reaction is given here. Besides using carbon to reduce metal oxides to metals, sometimes displacement reaction also used. This reaction means a highly reactive metals such as sodium, calcium, etc. are used as reducing agents because they can displace metals of lower reactivity from their compounds. One example is given here when manganese dioxide is heated with the aluminum powder. Aluminum is a highly reactive metal. The reaction is given below. The displacement reactions are highly exothermic. That's why the amount of heat evolved is so large. So the metals produced will be in a molten state. The reaction of iron oxide with the aluminum is used to join railway tracks or the cracked machine parts. This reaction is known as thermit reaction. The chemical reaction is given here. Next one is extracting metals towards the top of the activity series. As we know that the metals high up in the reactivity series are very reactive. These metals have more affinity towards oxygen. This is because oxygen is very abundant in nature and it is very reactive element. And these metals can be extracted by using the process of electrolytic reduction. For example, sodium, magnesium, these are obtained by electrolysis of their molten chlorides. In this process, metals are deposited at cathode and chlorine is liberated at anode. The metals are deposited at the cathode and chlorine is liberated from anode. The cathode is the negatively charged electrode and the anode is the positively charged electrode. When we use molten NaCl as electrolyte and when we activate the power supply, the Na plus that is cations that will attract to cathode. That is cathode is the negatively charged electrode and Cl minus that is the anions is attracted to anode that is the positively charged electrode. The next one is refining of metals. The impurities which must be removed to obtain pure metals. The most widely used method for refining impure metals is electrolytic refining. In this process, the impure metal is made as the anode and a thin strip of pure metal is made as the cathode. And a solution of the metal salt is used as the electrolyte. On passing the current through the electrolyte, the pure metal from the anode dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the cathode. The soluble impurities go into the solution, whereas the insoluble impurities settle down at the bottom of the anode and are known as anode mud. These are steps involved in the extraction of metals from its ore. Three types of metals we already discussed, and its extraction is given below. Next one is corrosion. The refined metals are trying to convert it into more stable compounds such as metal oxides, metal sulfates, or metal hydroxides. This is simply called as the corrosion of that metal. For example of the corrosion, when iron is exposed to moist air for a long time, acquires a coating of brown flaky substance. This is called as rust. Next example is silver article become black after some time when exposed to air. This is because it reacts with the sulfur in the air to form a coating of silver sulfate. Likewise, copper metal react with the most carbon dioxide in the air and slowly lose its shiny brown surface and gains a green coat. This green substance is basic copper carbonate. Next is how to prevent the corrosion of different metals. For rusting of the iron can be prevented by painting, oiling, etc. And galvanization is the method of protecting steel and iron from rusting by coating them with a thin layer of zinc. The galvanized article is protected against rusting even if the zinc coating is broken. The alloying is very good method of improving the properties of a metal. The properties of any metal can be changed by mixing it with any other substance. This is called as alloying. The substance added may be metal or non-metal. An alloy is an homogeneous mixture of two or more metals or a metal and a non-metal. This is prepared by first melting the primary metal and then dissolving the other metal in the definite proportion. This is then cooled to room temperature. This is how we can make the alloy. For example, iron is the most widely used metal, but it is never used in its pure state. This is because iron is very soft and stretches when it is heated. But if it is added with a small amount of carbon, it becomes hard and strong.